To find these formulas for an nth partial sum, what you're being asked to do is basically plug these numbers in for n in the problem and see if there's a pattern for what this thing sums to when we start adding these things together. Remember, this means that we're going to sum the sequence elements when we start plugging in the numbers. So we're basically creating a sequence by plugging in the numbers, but then we're going to add them together. All right, so when we have n equals 1, we end up with the square root of 14 minus the square root of 13. When n is equal to 2, we have the square root of 15 minus the square root of 14, but we add to that, right? Remember, when we do a series, we're adding the previous element, so we're adding this to it. So we're going to add the square root of 14 minus the square root of 13. All right, and if you see what happens there, that cancels out, and we end up with the square root of 15 minus the square root of 13. When we extend it up to n equals 3, the 14 is going to cancel, the 15 is going to cancel, and we end up with the square root of 16 minus the square root of 13. Partial sum, you can see that we have, for the first partial sum, it's 14 under the radical minus the square root of 13. When n equals 2, it's 15 under the radical minus the square root of 13. When n equals 3, it's 16 minus the square root of 13. So it's always 13 more than this number underneath the radical minus the square root of 13 is always what we get when we take the nth partial sum. All right, and then because the square root function grows without bound, this nth partial sum will grow without bound. Eventually, this just takes off to infinity, and subtracting the square root of 13 is not going to do anything. So this series diverges.